Hi everyone, welcome to another PyTorch Lightning 1.6 release live stream. Today we have with us Thomas, and we'll be discussing about fault tolerance training. So if you have been using AWS instances like on-prem instances, and you're worried about your builds while training your models, and you want to use spot instances and ensuring that your training doesn't break, then fault tolerance is the key. So we'll explore more like what is fault tolerance, why is it even important, and how it can help you save cost a lot. So let's welcome Thomas. Hey, hi Thomas. Your mic is off, I think.
Oh, hey, Rohit. Hi, everyone.
Hey, hi Thomas. So let's start with your introduction, and then we can explain fault tolerance.
Yes, definitely. So I'm Thomas. I'm PyTorch Lightning tech lead. I've been working um, on the framework for like close to 2 years now. So I'm going to talk about fault tolerance today and why you should care. So I prepared a couple of slides, but I think before diving into them, we can just like quickly introduce some of what this thing means and why that actually brings some value. So when we talk about fault tolerance, what we care about is the ability to save money at scale when we train in the cloud, right? So if you are training on spot instances, your training gets automatic cleared, and what you want is the ability to restart from that point without. Yeah, actually, just one sec. Wait.
Mhm. Also, during the stream, feel free to ask any questions if you have any time.
Yeah, okay, sorry, I had a tiny issue with my
Mhm.
computer that was buzzing me. Yeah, okay, so I'm going to share my slides. I think that would be just simpler to guide the conversation.
Yeah.
Okay, up, let me share my slides. Can you see the slides, right?
Yes.
Okay, perfect. So I'm actually going to start with a quick introduction around the Lightning API, Lightning, and then I will dive a bit deeper into Lightning fault tolerance. Okay, so PyTorch Lightning as a high level, what we want to do here is do research quickly, but usually people spend a lot of time on engineering, not the research, right? Which is what you care about as a researcher. And that's what PyTorch Lightning enables, right? It takes care of all the boilerplate, all the engineering, so you can really focus on what you care about, which is the research. To do that, we have a couple of components: Lightning module, Lightning data module, trainer, callbacks, torch metric, Lightning accelerators. I'm going to go through those very briefly for people who have never and who are like just discovering PyTorch Lightning for the first time. So the first one is a Lightning module. So the Lightning module is a component which contain most of the research. So that's really like where your PyTorch model lives. And it's very easy to convert from pure PyTorch. You just have to move your model inside of the init method, implement the training step, implement the configure optimizers hook, which returns the optimizer, potentially also the schedulers, and you are good to go. The second component is the Lightning data module. That's where the data loaders lives. What you can do is implement the train data loaders, val data loaders hooks, and you are good to go. So the nice thing, once you have those two components done, you can match them and compose them through the trainer. So you create this component called the trainer, and then you can feed, validate, test, and predict directly with those two components. So that's a very simple interface. The trainer provides a lot of features, and that removes a lot the boilerplate code. There's also callbacks, which enable encapsulation of certain functionalities and enable extending PyTorch Lightning. The last ones are metrics. So we have this library called Torch Metrics, which come with 80 plus metrics built in, which works with plain PyTorch and support distributed training. Okay, I'm going to skip that. Okay, so now I've presented PyTorch Lightning. We are going to dive into fault tolerance and why you should care. So fault tolerance is basically automatic checkpointing at the batch level for the cloud. So why should you care? So when you're training in the cloud, you basically have two types of machines, on-demand and preemptive. So I took this screenshot from AWS EC2 Spot, and they claim you can get like a 80% discount if you're running with Spot instances, right? So that sounds amazing. You are like, wow, that's great. I can use Spot instances and really reduces my cost. But the question you might ask is, what's the catch, right? Why is it? So the catch is preemptive Spot can be killed at any time, right? So when you launch a training, let's say with in the cloud, instances can be killed at any time, right? So what does that mean? It means that your script has 2 minutes usually, so that number can change between the cloud providers, but you usually have 2 minutes to gracefully checkpoint, right? So on a technical note, what's really happening here, the cloud sends a SIG-term signal to your script, and your script can register a signal handlers and perform some actions, right? So here will be saving the weight of the model or something like that, right? So I guess the next question will be how to gracefully checkpoint, right? So I think there's a couple of strategy and consequences which might come around, but the first one will be if you are to checkpoints every epochs, which is the most common one, you have lost the current epoch progress, right? So the second one will be, imagine you could say, okay, I want to checkpoint every n batches. But the thing is, it's actually quite expensive in terms of time, right? So that might make you training slower, and you're basically burning a bit of money there, especially if you are training on large workload. The last one will be you try to track everything and you checkpoint only when you receive the signals, right? So track everything is a very broad term here. I will dive a bit deeper into what this thing means, but if you were to know exactly where your training is at any point in time, then when you receive the signal, you can just checkpoint, right? So that's really equivalent to like a non-failure, right? Because if you checkpoint when you have tracked everything, then when you restart from that checkpoint, you continue exactly from where you were, right? So this is equivalent to non-failure, and it can be faster than the second strategy, which is checkpoint every n batches, especially when n is a very small number, right? So what's the catch with the third one? Like, it's actually quite hard to do in practice. There's a lot of moving pieces, like which need to be accounted for, and that's what PyTorch Lightning offers, right? So fault tolerance, what does Lightning offer? So actually up, cool. So PyTorch Lightning has a built-in for the third strategy, right? Which is we track everything, and we start a checkpoint only when the signal is being received. So what does the framework tracks, right? So first is 2Ks, but they are both supported. So there is DDP, so that's when you're training with multi-GPUs. There's a little bit more things to track. So I'm just going to talk about the first case, right? So you have the normal checkpoint, which is generated without fault tolerance, and that includes the weight of the module, of the buffers, the state of the optimizers, the state of the schedulers, and so on, right? But if you really wanted to make your entire training tolerant, you need to know the progress of the loops. So how many iterations you have done across like all the different loops. So in PyTorch Lightning, all the loops are encapsulated. So it starts with the training loop, and then it goes into the batch loop, and then it goes into the optimizer loop, meaning that we need to keep track of all of those, right? Another one would be metrics. So if you were to do the training and you had, let's say, your logs pushed to TensorBoard or 1DB or any loggers you are currently using with the framework, you don't want to see a cut in your epoch computation, right? So when you, if you were to get your spot instance like killed by the cloud provider, and then if you were to restart from this checkpoint, you don't want the metric at the end of the epoch to look wrong, right? So PyTorch Lightning also aggregate and collects all the metrics to make sure that we can restart properly and get the right metric at the end of the epochs. And then there's the last part, which is tracking the current batch, the random seed, and the sampler progresses. And that's actually the part which is the hardest, because everything else is things that Lightning has access to, right? So we know about the weight, we control the loops, we control how metrics are computed and aggregated, but the code you implement around your data loaders and your data set is really up to you. Like, we don't have control on what you do, and that's why you have so much flexibility, but that's also why creating an automatic version of fault tolerance is so hard. So to enable that, there's a couple of things, right? So what does Lightning offer? So when we talk about tracking current batch, random seed, and samplers progresses, there is this kind of question: can we automate this, right? So if yes, then you have nothing to do on your script side, right? So you just enable fault tolerance, and Lightning just runs. When there's a failure, it just automatically saves gracefully a checkpoint, and you are good to go. Now you can restart exactly from wherever the failure happened. If you can't automate this, then you need to help Lightning. And by that, it means you need to make your data set and samplers stateful. So let's talk about the automatic fault tolerance first, right? So what's supported? So a single map-based dataset is always supported. So to do that, you simply subclass a built-in dataset from PyTorch, implement the getItem and length methods, and we will collect automatically everything around it if you don't use like any custom samplers, right? So if you were to just get your data set, pass it to PyTorch data loader, say you want a batch size of 8, for example, and just give that to Lightning, then Lightning will work out of the box with fault tolerance. We will collect the random seed, so we will know exactly, we will be able to restore the transform exactly where they failed. We'll be able to collect how many samples have been iterated through the samplers and all those different things, right? So you can see these things in the documentation, and I will dive into this a bit later. So what is sometimes supported, right? So yeah, sorry, my slide doesn't really render exactly as I wished. So yeah, I should have checked that a bit more. Okay, cool. So what is sometimes supported? So I think the component which is the hardest is really the iterable dataset, right? So iterable dataset is a specific kind of dataset where you have to implement a iter method, and you just and that return a generator where you will yield the samples, right? And the part here, especially if you look at this piece of code there, where I have this 4 in range of self count, yield a random tensor, like this iteration is encapsulated inside of this function. Lightning can't introspect that and automatically track the progresses. So iterable dataset in if you use a sampler which is accessible from the outside, then that's something Lightning can access and use to track the sampling. But we don't have this, like, you will have to rely on the sampler. Otherwise, we can support it, right? So here you might say, okay, I have an iterable dataset, and I would like to use this feature because it could actually save me some money in the cloud, right? How do I do that? There's an answer to this, which is manual fault tolerance, right? So what you need to do is make your samplers datasets implement this API, which is what we call stateful. So we have this protocol, which is going to check your classes and make sure that they implement those functions, right? So you need to implement 2 functions, which is stateDict and lossTakeDict, on your samplers and dataset. So stateDict returns the state of your sampler. So you will return, for example, so if you didn't have, let's say, so if we were about a sampler, it will be what was the seed you use for generating the indices. For example, for when you generated like a permutation, for example, there will be anything you might actually need to restart your components. For load state dict, you will receive whatever you return from the state dict method, and you will be able to restart your sampler. So I have actually here an example of a random fault tolerant sampler, right? So I took the random sampler from PyTorch and I just made it fault tolerant, right? So here's how it works. So this sampler, as I said, needs to implement a couple of functions. It needs to implement state dict, the load state dict method, and one thing which is important but a bit hard sometimes to implement, it's a restarting strategy, right? So let's take this simple use case of the random sampler. So the random sampler take a map data set. So let's say an array of 100 elements. It's going to randomly permute them, and it's going to return one after one, like one after each other, right? So if you wanted to make this thing fault tolerant, you get this array of 100 elements, you permute this thing, right? And you start returning some of those elements. At some point, the iteration is going to be broken, right? That's not something you can control, but it's going to be broken. And you can return something for the state dict. So you are going to return your random state, and you are going to return a counter. So the counter is how many samples have you actually delivered until now, right? And when you restart, what you need to do effectively is create the same permutation as you did before the failure. And you need to skip all the elements that you previously delivered, right? So if you had those 100 elements sampled in permuted in a specific way and delivered only 20 samples, so you will have to skip those 20 samples and then start iterating from them. So actually, let's dive a little bit inside of the code. That's what I had here. On restart, previous indices need to be skipped. Okay, so let's just focus on the first part. So you create the generator from a random seed. You instantiate the counter to 0, and you say restarting equal false, right? In state dict, you return self.state, and in counter, you return self.counter. On load state dict, the strategy is the following, right? So you restore the generator state, right? So you have the same permutation as you had before. You reset the counter, and you set restarting equal true, right? So if we look back again in the iter method, there is this kind of if-else condition where we can decide what to do, right? So I think I had a zoom here. Okay, cool. So here is the iter method. So I still have the same, let's say 100 samples, which is like the length of my data source. I have the same generator, so I can create the same permutation as I did before failing, because the state of my generator is the same. And now if I'm basically restarting, I'm going to skip all the elements of those indices, right? So self.counter equals 0. I'm going to say restarting equal false, and I'm going to yield all those indices and increment the counter. When all this iteration is done, I can reset my counter, and that will be used for the next iteration. So I'm going to skip that and say, okay, so how do you enable fault tolerance, right? So right now it's supported through an environment variable. So if you want to enable automatic fault tolerance, you can simply say pl fault tolerant training automatic Python script.py. If you want to activate the manual one, you just say pl fault tolerant manual Python script.py, right? So it's really up to you if that's something you want to do. If you want to do automatic, there will be some use case. Lightning has an validation mechanism, so you can just try automatic. If it works and doesn't fail, then it's great. You can continue. If it's not supported, so yeah, it will be like you have multiple data loaders, or you try to you enable val check interval, so you're overlapping the training and the validations, and that will break too. So if that doesn't work by default, then you will have to implement what I said above, which was making your component stateful and implementing this restarting strategy. And once that's done, you can activate the manual mode with PL fault tolerant training manual. So I guess okay. So I had one extra slide for questions, and then there will be a demo and a quick code diving. Any questions so far?
Yeah, I don't think
Okay,
they
I
have
guess
any
not. So
questions.
I'm going
Yep.
to keep going. So yeah, so if you want to learn more, you can go to the PyTorch Lightning docs. So we recently reorganized our docs, so everything is easier to discover. So fault tolerance can be found under Level Up. Level Up is different way for you to learn about Lightning and learn about deep learning in general. So you start with like some basic skills, intermediate skills, advanced skills, and fault tolerance is really at the bottom, expert skills, right? So you might not need it, but if you are really trying to save cost in the cloud, then it's a great way to do so. So you can click here and you get all this information I shared about and how to enable it, right? So one extra thing I wanted to quickly share is PyTorch Lightning is extended by this platform, Grid.ai, and they have a direct support for fault tolerance in the cloud. So if you wanted to do that, you can just say, instead of saying Python script.py, you can just say grid run uspot auto resume means.py. And what this thing does is every time uspot instance is going to die, Lightning is automatically checkpointed, right? So we automatically create this checkpoint, and your experiment is automatically restarted, right? And it will continue until your script finish. So if you were to, let's say, train some models over the weekend, right, where you might launch some training on Friday, and you want them on Monday, like maybe like if you were to train on spot instances, like they will die in the weekend, right? And you will be like, oh damn, I lost everything, right? I will have to relaunch them. But here, the training could fail 10 times, 20 times in the weekend, and automatically Grid will restart them from the latest checkpoint, from that fault tolerant checkpoint, and really go forward until the end of the training. So that's for Grid and the framework. I'm going to quickly show a demo. So if you go in, if you clone PyTorch Lightning, go inside of PL examples, fault tolerance, you will see this automatic.py file. I didn't implement a manual one. That will come definitely in the future, but let's quickly talk about the automatic one. So I created this example. There is an explanation here on how all these things work. So what you can do is simply run that first command, which is Python PL example fault tolerant automatic. What this thing does is it's going to run a simple model, right? So a simple MLP. And here we can see that PL fault tolerant training has been activated with automatic. And that's going to train for, I think, like 9 batches, right? At the end of the training, we get those weights, right? So we get the weight of the model as the following, right? And here I'm going to show the fault tolerance version of it. So to make that simpler, I am kind of blocking the code on the first batch, so I can really show you this kind of kill seek term approach. So If you want to run it this way, you just need to say emulate kill signal, right? So I'm really emulating this thing, but in the cloud, it will be the same mechanism, right? So here, what I'm actually doing is on the fourth training step, I'm basically waiting forever, right? So I'm waiting for another process to kill me. So here you can just copy this thing here, kill sig term and the PID, right? So here you can just do that, and here you can see that the signal was received and it was properly killed. So here, if you see saving a fault-tolerant checkpoint and terminating, it means everything just worked as expected. It's great. And here we can see the training basically stopped mid-epoch, right? And the checkpoint is actually right here. So it's actually a PL autosave checkpoint. It's different from the traditional checkpoint we create. This one is really meant to be fault tolerant. It's actually augmented with loop tracking metrics and all those different things, right? If you want to restart, you just have to run the same command. And here's a very cool thing, right? So PyTorch Lightning, if it runs with a folder where this kind of file exists, it will automatically pick it up. And that's why when you run in the cloud, this thing just works, because when we fail, Grid just snapshots the instance with like all the artifacts and then just relaunch it automatically. And then as this checkpoint is available, it would just be reloaded and everything just keep going as it was. And it means you really don't lose any time, right? It's like, and you can reduce the cost of your training by a very large margin. Like if you look at, again, if you look at AWS, they say you can save up to 90% or something. Okay, and then if you want to do it again, you just run the same command. And here we should see that, and I'm just going to quickly show that. So that's what we just got, right? So that's like the weight I received after reloading the checkpoint. And here is what I had the first time when I run. And if I'm not mistaken, we should see exactly the same values. Yes, that's exactly the same, right? So what that means is training with fault tolerance is exactly the same as if no failure happened. And in the cloud, that can save you a lot of money. Okay, I think I'm close to time. I've covered everything I wanted. There might be some questions.
Yeah, right now there are no questions. So I think we can wait for a few minutes and see if there are any questions come up. But I have one. So
Yes.
does fault tolerant works with the cases if you're using, like, let's say starter training, using deep speed or something?
Yeah, so it just works with all the built-in of PyTorch Lightning. Like so PyTorch Lightning supports checkpointing for like all the different strategies, right? So for like
Hmm.
DDP or DDP with sharding, like provided for like with like FSDP or deep speed. But the part which is really complex for the framework is data loading. So if you support that, so if your data set can be automatically handled, then great for you. Like you can just go forward with that feature. Otherwise, you can implement the kind of manual, like make your samplers data set stateful, and you get full range of the feature and at scale, right? So you could train like trillion size models and get this feature out of the box.
Got it. So if you guys have any questions, you can ask. Feel free. Anything.
Yeah.
So is right now fault tolerant is in beta, or can we expect like it works in all the cases?
Yeah, I think PyTorch Lightning has, I will say, a very strong beta, and I think we will potentially have fault tolerance in a stable way for 1.7.
Got it. Awesome. So it looks like we don't have any more questions, and maybe we can end the stream.
Yeah, sounds good.
Awesome. Uh, have a nice weekend, everyone.
Yeah, bye everyone.
Bye, everyone.